So we have here this problem. We are going to fence in a rectangular field, starting at the bottom of the field and moving around the field in a counterclockwise manner. The cost of material for each side is $6 per feet, $9 per feet, $12 per feet, and $14 per feet. If you have $1,000 to buy fencing material, determine the dimensions of the field that will maximize the enclosed area. So since this is a rectangular field, and the problem stated that we would start at the bottom, so this would be the 6 first because it was respectively 6, 9, 12, and 14. So we would just add the two lengths and two widths, and we have our formula. A is equals to length times width, and we will also be using that later. So we have the $1,000 is equal to $18, 18 length plus 23 width. To get the length, we would transpose the 23 width to the other side so that the length would just be cancelled out. 18 divided by 18 is just 1. So we have the length here. And then now we can use the formula, length times width. So since we have the length from what we did before, we can substitute the 1000 minus 23W over 18 and cancel the 18. So after that, we can substitute the 23W to the 1000 minus 23W. And after that, this is what will be the result. And then we can use our first derivative theorem, which is the power rule. So 23,000 W, it would be 23,000, and then the 529 W squared would just become 1058 W, and equate it to 0 so that we would get the width, transpose the width to the other side, and then divide both sides by the width so that this would be cancelled, and then divide this. The result of this would be 21.74 feet. Now we have the width. So our length before was 1000 minus 23. Then substitute the W, which we already have, 21.74, and then multiply and then subtract. So what we would be getting is the 27.78 feet. And that's all.